Hi, my name is Rick Chin. I'm a co-founder and the VP of Software Development here at Desktop Metal, and I'm here to tell you about our software. Now, before I get into the software, I want to give you a little context. Now, the whole reason that Desktop Metal exists is we want to make metal fabrication easier than it's ever been before and more accessible. And that's because today, metal fabrication is really hard. Whether you're doing traditional subtractive techniques like milling and turning, or some of the new metal 3D printing techniques like DMLS, they all require big infrastructure. The equipment and the materials are expensive. You need a dedicated operator for these machines. And Desktop Metal is looking to change all of that. We're going to get rid of the requirement for big infrastructure. Everything's going to be more affordable, and it's going to be easier to use. And the software is a big part of that, making things easier to use. So I'm going to take you through the software and show you some of those ways that we're accomplishing that. Okay, this page that we're starting on right now is called the dashboard, and it's essentially your home screen in the application. If you've got a job running on the printer or the debinding unit or the furnace, you're going to see it front and center here on the screen. You've got a 3D view. You can see exactly how the job is progressing. You can see what's still left to be printed here with the translucent representation above. You can see the device that it's running on and what material is loaded, and even how much of the material is there. Over on the right-hand side of the screen, this is where we actually have instructions that are ready to be put together to define the next job in the process. Again, whether you're printing or debinding or sintering something. But over here on the left-hand side of the screen is where you start the process. So I'll click on the button here to upload an STL file of my model. Now, in addition to being able to take an STL file of something, we're actually supporting the ability to read in native files from your CAD system. So you can directly read in a SolidWorks file or CATIA or ProEngineer or Creo directly into Desktop Metal software. And the great thing about that is, one, it's more convenient for the user because they don't have to worry about creating this intermediate file format. And second, we know what the optimal tessellation or tolerance is for the mesh. And so we automatically create it and then load it into our software. Here we have a 3D thumbnail of the model, so you can see exactly what the size of the model is relative to the build volume on the printer. Here you have the opportunity to specify the units for the part. In this case, it's millimeters. We're going to accept that. And that brings us to the Fabrication Instruction Screen, or the Fab Instruction Screen. So again, we get a 3D view of the model that we're working on. And it's on this page that we tell the system, this is what we want the end result of the process to be. So once the part is done printing, debinding, and finally sintering, this is what I want the part to look like. This is the material I want it to be made of, the size of the part, like you can tell the system I want it to be a 50% size model or maybe a 2x size model of the part. And then you basically tell the system what you want your intent to be for this model. A very important design philosophy for our software is that we want to make it so that you're going to be successful whether you're an expert or a brand new user to our system. And so there's a lot of things that experts know about 3D printing that we take out of the hands of the user. Here in the interface you can see I have the opportunity to specify the orientation that I can print this model. And whether I'm printing my model like this or like this or like this, any orientation has its pros and cons. And again, an expert user knows what those benefits and those cons are. In addition to that, you can specify the parameters. You know, what should the extrusion rate of the material be? How fast is the velocity of the head? What's the temperature of the nozzle? And what we've done is we've pre-configured two different parameter sets, one with a thick layer thickness and one with a thin one. So it can either print quickly or print with a better surface resolution. Now, an expert will know what combination of orientation and parameter file they want to accomplish a certain thing. But if you're a new user, again, that's not really that obvious. So you know what we've done is on the upload of this model to the Desktop Metal Cloud, we've actually pre-calculated the 12 combinations of the 6 orientations and the 2 parameter files for you. And down here on these sliders, we show you the range of the good end of the spectrum and the bad end of the spectrum to produce this part. What's the minimal amount of time to print it? What's the maximum amount of time? Same thing with the amount of material that's consumed or maybe the surface quality. So watch, as I change the orientation of the model, watch the sliders change position, again, to reflect the relative goodness, and good is on the left, or the badness, where bad is on the right. And you can see all these sliders move to the right-hand side. So it's telling us this is probably a pretty bad way to print the model. And if you look over here on the screen, anybody that's done any 3D printing would look at that and say, you know what, there's no way I would ever print the part that way. And the system is telling us exactly that. So we can step through and look at a couple more orientations, right, and see how they compare to one another. Now in this orientation, again, to the left is good, to the right is bad. You can see that from a material usage standpoint, we're using quite a bit of material. And remember, when we print our part, we're using the same material for the supports as we do the part itself. And so different orientations will consume a different amount of material. Down here on this slider, we can actually look at the part, look at the supports, right, or everything in between. So if we look at the support representation, we can see the amount of support material created. You can see in this dark purple, that's the special interface layer that we're printing. And that's one of the many innovations that are in desktop metal. This actually allows us to create supports and have the part actually just pop away, rather than you having to grind or cut away the part from the supports. Actually, you can do it all without any tools. What I'm going to do now is let's look at the part and the supports together. And again, you can see there's quite a bit of support material relative to the part. Well, back over here on the sliders, again, they tell us the good and the bad, but not only that, it actually acts as an interface to let me say, you know what, what's the best way to print this part with the minimal amount of material usage? So I just pick on the left-hand side of the slider. It reorients the part, it changes the parameters, and you can see in the graphics window that we're using significantly less support material than in the other orientation. Or I can come over here and select on the left-hand side for surface quality, and it automatically orients my part to give me the best overall surface quality. Or again, I can click up here at the top and I can say, you know what, what's the best way to just print this part as fast as possible? And so again, we're giving the user the opportunity to specify what my intent is or what my objective is for this part, and then it will figure out for me the best orientation and parameter file to accomplish just that. In addition to specifying my objectives for the print, I can look at the toolpath that's being generated to construct this part. I can come over here to the slider, right? I can drag it up and look at any one of the layers, right, as this part is being printed. Each one of the colors represents a different kind of, or a different portion of the tool path, whether it's the support geometry or the infill or maybe the outer walls of the part. I can come in here and turn things on and off depending on what I want to look at. Okay, so it gives me a good way to kind of confirm that, yeah, I like what the tool path looks like and what the system's going to give me in the end. So again, this page, called the Fab Instruction Page, is where the user says, okay, this is what I want the end result of the process to be. Now that I'm satisfied with what I've specified, I can hit continue. And it's at this point that the system generates the instructions for printing, debinding, and for the furnace to center the part. So then, after it's calculated those instructions, it brings me to the first step of the process, which is printing the part on the printer. So we're showing the part on the platform of the printer. I can print just one, maybe I want to print three, maybe I want to print some other parts. I can click on the checkbox of another part, and I can actually see the parts nested on the platform. Over here, you can see that one of the parts is actually grayed out and is labeled as non-compatible. And what that means is there's something about this particular part that won't let me print it with the rest of the parts that I have on the platform at the moment. And it could be things like the parameters aren't compatible in some way. The part won't fit on the platform given its size, or maybe it actually, by adding this part, we exceed the maximum printing weight that the printer wants to handle. So I have the ability for the system to tell me those kinds of things, again, without me having to be an expert on any one of these steps in the process. Now what I'm going to do here is let's turn off these components. I'm just going to print the one. And I can come over here to select the printer that I want to send this to. Now you can see that I have a range of printers available at my organization, and I can see the printer, its name, I can see its status, whether it's idle, it's busy. I can see what material is loaded on that printer and how much material is available. And that's one of the many benefits of having a cloud-based solution, where not only do I run the software on the cloud, but all my devices are connected to the cloud as well. So I'll go ahead and select this printer and send the part over to it. Now I'm going to go over to the display for that printer, and this is the same display that you see on the console. And you may remember that in the printer list we saw that this particular printer was busy, and it is actually printing a part. We're going to cancel that, and if we look up in the queue, we can see the hinge part that we've been working on is now available. So I'll select on it and then say Start Print. And the system will download the model to the printer, begin the printing process, and you can see here we get a rundown of how much time has elapsed in the printing of this part, how much time is left, what layer we're on, and what the status of the machine is. In this case it's good, and again the status of the material on that printer as well. If we go back to the dashboard, right, again, when I started my presentation, at the very beginning I mentioned that if I've got a job running, that's what's front and center, that's what's taking up all the real estate in this view. We can see the part, how far along it is in the printing, both graphically, right, and in the progress bar. We can see that we're 9 minutes in, how much time is left, which step in the process we're currently at. In this case it's printing. Since we're running on a printer, we can see which printer it is, and again, what material is installed and how much material exists on the printer. And I can not only look at this dashboard here on my desktop computer, but I can look at it on my iPhone or my mobile phone as well. And the great thing about that is we've designed this to be a responsive web app, so it's optimized for that particular device. When I pull my phone out, I can look at it and it'll tell me immediately that everything is A-OK, how far along the job is, and when I can expect it to be done. And when I check my phone, right, I'm typically doing it not when I'm at my desk, but I'm away from my desk or maybe out of the office. And so it's a great way to see exactly what's going on with the jobs that I'm running. So again, just to recap, the whole purpose for Desktop Metal to exist is to make metal fabrication more accessible. And we're doing it by getting rid of the big infrastructure that has been typically required up until this point. We're making the machines and the materials more affordable, and we're making the whole process easier. And that is the whole purpose of our software, which I've just been demonstrating to you, where we've designed it specifically to make it so that you don't have to be an expert to be successful with our software. Thanks for the time, and look forward to you being a customer.